Okay, so we would like to compute this limit, the limit as x tends to 1 of x to the 6th minus 1 over x to the 7th minus 1, which is obviously an indeterminacy of the form 0 over 0. So we can do this in two ways. The first way would be to actually use synthetic division. If we apply synthetic division to both the numerator and the denominator and divide by x minus 1, then actually, let me write it from the beginning. So x to the 6th minus 1 over x to the 7th minus 1 is going to be the limit as x tends to 1 of x minus 1 times x to the 5th plus x to the 4th plus x to the 3rd plus x to the 2nd plus x plus 1 over x minus 1 times x to the 6 plus x to the 5th plus x to the 4th plus x to the 3rd. I know it's long. Plus x squared plus x plus 1. And, once the x minus 1s that are responsible for the 0 are gone, then we get this quotient. And obviously, we can right away plug in x equals 1. There is absolutely no problem doing this. And when we do so, that will give us the limit 6 over 7. Before I jump to the second way of solving this problem, I would like to just show a synthetic division. So let's say that we want to do let's do the longer one, the x to the 7th minus 1 by x minus 1. So you want to put the coefficient, so 1. Then you will have 6 zeros. 2, 3, 4, 5, 6. And then you have negative 1. And you want to put an 1 down here. And then it's the usual thing. 1 times 1 is 1. And you will be getting the same thing over and over and over, till eventually you get a 0 right here. And that justifies or shows how this synthetic division is done. However, once we have L'Hopital's rule can settle this in a much more elegant way. So by L'Hopital's rule, we can consider the quotient of the derivatives. And this is the limit as x tends to 1 of 6x to the 5th over 7x to the 6th. And you see now what happens. This is very, very simple. You just plug in 1 and you get 6 over 7 in a heartbeat. And of course, you have to acknowledge that the initial limit is 6 over 7. But, this certainly less work, which shows, after all, the power of derivatives. L'Hopital's rule is obviously based on derivatives. And that's all. Thanks for watching.